Hi, in today's video we are going to look at a very interesting problem of Netherlands Mathematical Olympiad of 1990. The question proved that for every integer n, as n is strictly superior than 1, we have this inequality: 3 is multiplied by 5 is multiplied by 7, and so on and so forth, until we get the last term, which is 2n minus 1. The whole thing is strictly inferior than n to the n, okay? Go ahead, pause this video if you would like to give it a try to this problem. When you are, come back to see the full solution. Let's get started now. I'm going to prove this one by using induction hypothesis. So I have this product. I'm going to check with the base case n equal to. I'm going to replace k with 2. So 2 is multiplied by 2, which is 4. 4 minus 1, which is 3. So that's mean 3 is strictly inferior than 2 to the 2, because I'm replacing n with 2. So this one is 4, which is true, because 3 is strictly inferior than 4. True. We are going to assume to claim this product 3 to the 5 and all the way down to n minus 1 strictly inferior than n to the n is true. We are going to prove for n plus 1, okay? N plus 1, which is, so this is our goal, okay? If we prove this one, that's mean our assumption is true, okay? So we claim this one is true, then we prove that one right here, okay? We have this true, so this product, I'm going to multiply this one, 2n plus 1 is multiplied by this one, and as k goes from 2 to k minus 1, strictly inferior than n to the n is multiplied by 2n plus 1, okay? So this one is the same thing as you have this one, 2k minus 1, as k goes from 2 to the n plus 1. Because if you replace n plus 1 as a last term, is giving you 2n plus 1, okay? That's why this one equals to this one, okay? So this one is strictly inferior than n to the n is multiplied by 2n plus 1. To prove that one right there is enough to prove this one, this term is strictly inferior than n plus 1 to the n plus 1. If I prove this one, this term, that's mean I have proved this one, okay? So this is our goal. I'm going to work on this one now. As you see here, n to the n, 2n plus 1 equal, I'm going to simplify this one, n to the n, 2n plus 1 equal n plus 1 plus n plus 1. I just distribute this one. I'm going to distribute this one. The first term is multiplied by this one, is giving us n to the n plus 1 plus the second term, which is n plus 1 is multiplied by n to the n. The whole thing, which is 1, is strictly inferior than n plus 1 to the n plus 1. So what I'm going to do now, I'm going to bring this term to the other side. So we'll have this one equivalent n to the n plus 1 is strictly inferior than n plus 1 to the n plus 1 minus n plus 1 is multiplied by n to the n. I'm going to put n plus 1 as a common factor, is giving us n plus 1 is multiplied by n plus 1 to the n minus n to the n. So that's mean n to the n plus 1 is strictly inferior than n plus 1 is multiplied by n plus 1 to the n minus n to the n, okay? In the last word I was working on this inequality and came up with this result. Now I'm going to simplify this one. This one is giving me n is multiplied by n to the n is strictly inferior than n plus 1 is multiplied by n plus 1 to the n minus n to the n, okay? I'm going to divide both sides by n to the n. So this one equivalent, this one it will be left with n on the left hand side. So this n is strictly inferior than n plus 1 is multiplied by this term, which is n plus 1 over n to the n. Okay, because I have divided both sides by n to the n, minus 1, because n over n to the n, which is 1. So now I'm going to divide both sides by n plus 1. Okay, this one equivalent n over n plus 1 is strictly inferior than n plus 1 over n to the n minus 1. On the left hand side of this inequality, I'm going to divide the numerator and denominator by n. On the right hand side of this inequality, I'm going to divide this quantity, the numerator and denominator, by n. Okay, so this one is giving me 1 over 1 plus 1 over n is strictly inferior than 1 plus 1 over n to the n minus 1. Okay, so as we know, we have n is n strictly superior than 1. It's an equivalent 1 over n is strictly inferior than 1. I'm going to add number 1 on both sides. I will have 1 plus 1 over n is strictly inferior than 2. Okay, for this term, I'm going to take the reciprocal of this one. I will have 1 over 2 is strictly inferior than 1 over 1 plus 1 over n. Okay, so as you have there, also we have this one, 1 over plus 1 over n. At this point, also, if I'm raising n as a power on both sides, I will have 1 plus 1 over n to the n is strictly inferior than 2 to the n. So now I have two things there. Now I have two terms. Now I have these two things. 1 plus 1 over n to the n is strictly inferior than 2 to the n. Also, I have 1 over 2 is strictly inferior than 1 over 1 plus 1 over n, which is strictly inferior than this term, which is 1 plus 1 over n to the n minus 1, equivalent 1 over 2 is strictly inferior than 1 plus 1 over n to the n minus 1. It's equivalent. I'm going to bring this one to the left hand side, so I will have 3 over 2 is strictly inferior than 1 plus 1 over n to the n. Okay, as we have here also, this term is strictly inferior than 2 to n. Okay, now I have 3 over 2 is strictly inferior than 2 to the n. I'm going to multiply both sides by 2, so we'll have 3 is strictly inferior than 2 to the n plus 1. Okay, now this term is true for all and is strictly superior than 1. Okay, so this one implies this term that I have here is strictly inferior than n plus 1 to the n plus 1. Okay, now I have arrived here because I start with this one. I found this one is true. That means this one is true as well. So that means our inequality is verified. So finally, thus this product is strictly inferior than n to the n for all n strictly superior than 1. Okay, now I have done with this problem. If you have any question or suggest, just put it in the comment section below. Thank you for watching. I will see you in next video. Bye.